And the first URL I'll give it, HTTP, go to my listing address, port 8000, and I'm going to ask to run scott.print, which is the procedure name, and I'll set the parameter tab to the table emp and the parameter col to the column ename. Run that, and back comes the ename column of the emp table. Alternatively, I could perhaps go to the table dept and ask for the column dname, and back come the 4 departments. That's all good so far. What if my end user tries to hack the system? Maybe he goes to a table that he isn't meant to look at, such as hr.employees. Try to go to a different schema and retrieve the column, say, last name from there. So try to break out of the security, and we can't do it. The code looks solid enough at this level. Well, maybe it isn't. What I'll do is go back to this URL that queries the dept table and put in a crafted variation that is intended to break the security. And my variation is this. I'm going to run scott.print, and I've set tab equal to dept, but then I've added some more. %20 union, which is a space of course, so that's effectively space, union, all, select, last name, from HR employees. And then I append call equals dname to the end. And look at that. I've got the contents of the HR employees table. It can be that easy to get a SQL injection if your code is not well written. What has happened is that my low privileged user apps, who can't do anything other than execute one procedure, has managed to steal the privileges of the developer. It's possible because the procedure didn't do any proper validation of the parameter string. And it is frightening how much production code out there is vulnerable to this type of attack. To defend against this type of security breach, the only solution is code reviews. Your DBA has to go through every line of code your developers are writing, checking it to see if it's vulnerable to this type of attack. It's a huge workload, and there's always the possibility that no matter how good your DBA is, that he might actually miss something. However, 12c introduces a technique whereby we can control this without having to do any code reviews at all. Your DBA can do it using a declarative technique and make your system secure against SQL injection, no matter how badly written the code is. The technique is to grant a role to the code, and that role will restrict what the code can actually do. The first step is to make a small adjustment to the code itself. So I'll connect as Scott and recreate the procedure. What I've done is I've added auth ID current user. I've converted this block of code, scott.print, so that from now on it will run with the privileges of the invoker, not the privileges of the developer. Then we create a role called emp.dept only, and grant that role precisely the privileges that this block of code needs, which are select on scott.emp and select on scott.dept. So that role is strictly limited. Then we grant that role to the procedure with grant emp.dept only to procedure print. And that's our new 12c capability. What happens now when we run the code? I'll try the first URL. My first URL was the one that queries emp ename. Back it comes. Then, just for completeness, let's try dept and dname. And there's the department names. We'll try the first crude attempt at a hack, and that was where I specified in the URL HR employees last name, and that fails. Now let's try the crafted URL. So this is the URL that puts in a union all query going to HR employees. We try that. No good. Why is it no good? Because the procedure itself is limited to only the nominated objects in the Scott schema. And this technique of granting roles to
invoker rights code
will make your system completely immune to a vast category of SQL injections. And this should be a major driver for the 12c upgrade, especially when you remember that your DBA can do it without having to go through the dreadful business of code reviews and debugging badly written software.